All right, in today's video, we are going to be learning about the fifth index law. So our learning intention is to learn the fifth index law. Our success criteria includes understanding the fifth index law and applying it to questions, using knowledge of bases, powers, and multiplication rules to questions, and being able to input powers into a calculator. So let's recap. In my previous video, I introduced the fourth index law to you. I have rewritten it here and boxed it in purple. Let's go through an example just to remind ourselves what we did. When we have a base to a power, okay, and all of that is inside brackets to the power of something else, or it can be the same number, but it's just to the power of. You take the power from the inside and multiply it with the power on the outside. Okay, so it's like we're doing this with the times sign. Okay, so it becomes A, that's our base, and our powers are multiplying together, which is the same as the powers next to each other with no gaps. Because we know that when there are no gaps between two things, there's an imaginary times sign in between them. So this equals the same as that. So let's practice with an example. Okay, let's say that we have h to the power of 8 to the power of 5. Okay, this is a h, not an n. So, if this is our question, the fourth index law states that we take these two powers here and we multiply them with each other. So the answer would be h 8 times 5 which is h to the power of 40. Now, what you could do here, instead of doing it in your head, is you could just do 8 times 5 in your calculator. Okay, like so, equals, that equals 40. So that's how I get 40 up here as my overall power for the answer. Okay, all this is saying is h to the power of 8, okay, multiplied by itself 5 times. Okay, this is the expanded form. Okay, so if you need to visualize what this question actually means, it is actually like this. And then instead of us taking our time working out the answer, we could just apply the fourth index law and know that we can just multiply these two numbers here and get the correct answer. All right, let's get into index law 5. Now, I will say that some of the last question I did in my previous video was kind of the fifth index law mixed with the fourth. It was a bit of an extension to the fourth index law, but that's okay because I'll go into the fifth one in more detail. So let's clear my calculator. The fifth index law states that when you have two variables, okay, in brackets, and then you have them to the power of something, so this m could be any number, all right, that means that this power out here on the outside of the brackets gets multiplied to everything on the inside of the brackets. So our fourth index law looked like this. Okay, pretend there's an imaginary 1 up there, and what you do is you take the outside power and multiply it to whatever power is here. This time we just have an extra letter or an extra variable. Okay, that's it. Otherwise, it's the exact same thing. This power out here needs to get multiplied to everything on the inside. Okay, same concept, all right? Very similar to the fourth index law. So I'll show you this in expanded form. What we've got is now our M is going to the top of our A, and that's being multiplied. And the M is going to the top of the B, and that is also being multiplied. So this power out here, you can see, has been multiplied to the A, to its power, and same to the B. Okay, so you're placing the M on top of the A and on top of the B, if you want to understand it in simple terms, okay? What's actually happening is over here where we have our AB, there are no gaps in between them, okay? There's no gaps in between the A and the B. Now, what do we know about when two things are next to each other when there are no gaps in between it? It means there's an imaginary time sign. So that's where this time sign comes from, okay? This actually means A times B, because there's an imaginary time sign in there, to the power of M, okay? Everything is to the power of M because M is on the outside of the brackets. Okay, and remember M can just be any number, okay? So to get from here to here, we are just getting rid of this time sign and placing the A and the B together because this equals the same as this. No gaps means imaginary time sign. Okay, so let's just pretend that our M actually equaled 3, let's say as an example. Then the 3 gets multiplied to the top of the A and the B, again, if you want to hear it in simple terms. Okay, and the reason why we can do this is because, remember, when there are no numbers written as powers on a letter or a number, okay, there's an imaginary number 1. So on top of this A and on top of that B, there is actually a number 1. So the reason why we can just multiply this 3 to the A and the B is because it's just 1 times 3 and 1 times 3. And that's how we get that. Okay, so let's practice with some actual questions now. I've got 4 again. The first, x, y, all in brackets to the power of 10. Okay, all we need to do is multiply this 10 to here and there. So our answer is x10, y10. The reason why I can do that is because there are imaginary number 1s as powers on the x and the y. So the 10 is being multiplied by 1 here and the 10 is being multiplied by 1 there. So we get so that's how we get our answer. Okay. Second one, exact same thing. I'm not going to show you doing this because you should know that there is an imaginary 1 over here. I'm just going to show you using the index law. All we need to do is take this 9, like so. So they're quite simple. All right, you just need to remember that with index law 4 and 5, which is this one, we're multiplying inside the brackets. Okay, that's what you need to remember. Index law 4 and 5 relates to multiplying. Now, let's go down to question 3 and 4. Question number 3, this time I have a power on one of my variables. On the other one, I have an imaginary 1, yes, but it's not written down. So it looks like there's nothing on the j, okay? Don't forget that that just means there's an imaginary 1 there. So what happens if there is another number other than an imaginary 1 on top of a letter, let's call it? Well, like I kind of did in the examples in my previous video, you just do that power that's already there multiplied by the power that's on the outside. Okay, so we end up getting the 3 has stayed on the h and I'm multiplying the 5 in. Imaginary times sign in between these two things. And then we've got an imaginary 1 on the j and we're multiplying it by the 5 on the outside. So we get h and then we get 3 times 5, which is 15, times j 1 times 5, which is 5. Oh, forgot the j. And then we can just bring those together. So our answer is H15, J5. If you need to use the calculator to figure out these multiplications, you just input them like normal. You don't need to do it to the power of anything. You would just go 3 times 5. Okay, and you'd get 15. Obviously, when you do 1 times 5, you'd get 5. Okay, so you just put those in like normal multiplications if you want to put those in your calculator because you can't figure them out in your head. Okay, last one. This time we've got, pardon me, numbers on top of my A's and my B's, okay, and they're all to the power of 11, which is on the outside. Okay, so what do? The exact same thing. We're multiplying. So take this number, multiply it to here, take that same number, multiply it to there. Okay, so let's write this out and make sure you show every single step of your working out. If you try and do this in your head mentally, you may forget a step, you might accidentally add them. It's so easy to make simple mistakes, so you need to show all of your working out exactly like I have. Okay, you know how often I tell you guys to write your working down so you don't lose marks and you take care in answering your questions, especially if you may be under the stress of a test or exam. Okay, write down your working out. All right, so we've got A, then we've got the 5 that's already there and we're multiplying it by 11. So 5 times 11. When there are two things next to each other with nothing in between them, there's an imaginary times sign. So times B, that's to the power of 6. Multiply that by 11. And what do you get? Well, A, 5 times 11 is 55. Times 6 times 11 is 66. Now we can clean this up by removing this time sign and we get an answer of the exact same thing but just next to each other with no gaps. Okay, now again, if you wanted to do these multiplications in your calculator, perfectly fine. you would not put them to the power of anything. You would just do 5 times 11, which gets you 55, and you'd also do 6 times 11 for this one to get you 66. Okay, so again, I'll move my page up. You can pause me here to write down the 5th index law, and then you can pause the screen here to write down the work examples.